Hello, welcome to Autodesk NetFab Simulation Lesson 4, Creating a Finite Element Mesh. In this lesson, we just want to cover how to create a voxel mesh in NetFab Simulation and how to modify that voxel mesh to get a mesh that's suitable for an analysis. So go ahead and launch NetFab Simulation. And the first thing we're going to do is, of course, import a geometry into whatever directory you want to work in. So we import a geometry, and I don't have any support structure here. This is just a part. Turn colors off, and my geometry is in millimeters. Okay. So now I've imported a part into NetFab Simulation, and this lesson is just going to focus on meshing and nothing else. So we'll go right to Analysis Setup, and then you want to enter the Analysis tab. This is where the voxel mesh is controlled. So the two entries here that control the voxel mesher are the accuracy and the minimum wall thickness. So first you want to enter a minimum wall thickness, which is just roughly the thinnest section in your CAD file. So it doesn't have to be an exact entry, just a rough approximation, and this is going to let us take an initial guess at what a reasonable voxel mesh will be, and then we can view that mesh and iterate using the mesh preview function. So I'll leave this minimum wall thickness at 1 millimeter. That's roughly the minimum wall thickness in the geometry that I've imported. And then I'll leave the accuracy at default. So increasing this accuracy to accurate would result in a finer mesh and slower run times. And decreasing this to fast is going to result in a coarser mesh but faster run times. And if I decrease this minimum wall thickness, again, I'm going to get a finer mesh and slower run times. If I increase that entry, I'll get a coarser mesh, and so on. So I'll hit OK. And now I'm going to use the mesh preview feature. I'll give this guy a name, hit save. And this is basically what's happening here is the solver is just interrogating this geometry very quickly, and it's determining where we have thin sections, where we have thin sections, and it's going to populate this automatically with voxels. So this is our initial cut at the mesh. So we can take a look at how the inside of this mesh looks here. So, and you can see we have about 1 element per these thinnest wall sections. So as a rule of thumb in NetFab Simulation, you want about 2 elements per these thinnest wall sections to capture the distortion of those sections. So we're going to go back now to the home page, back into Analysis Settings, Analysis tab, and we're going to select the Moderate Mesh setting. And this will allow you to see what these mesh inputs do to the result. So now we're going to hit Mesh Preview again. And in just a second, we have a mesh. So now you see the result is actually a finer mesh than what we had when we ran this initially. And if we use the clipping tool again, we can see we now have 2 elements per these wall thicknesses. So this is a suitable mesh to run through the analysis. And another thing to notice with the mesh is that it can handle, this is unique to this solver, it can handle hanging nodes, they're called. So a node like this node that doesn't share a node with a neighboring element. And that becomes a constrained node. And this allows us to coarsen the mesh very aggressively away from where we have fine geometric features. So where we have fine features like this, we can use small elements to capture that detail, but then the mesher is also smart enough to know that in the build plate where nothing interesting is happening, we can get away with coarse elements. So this allows us to keep the number of degrees of freedom very low in the analysis, and it's one of the reasons we can get such fast analysis run times. So just to summarize what we went over, we covered how to modify your mesh settings and how to create a voxel mesh that's suitable for the analysis. In the next lesson, I plan to cover how to edit boundary conditions in the analysis.